All right. So I have this slope, and that's my m, and I'm just going to use one of these 2 points. So I'm going to use this point. This is my x, and that's my y that I'm going to plug into my equation. So
Oh, yeah. I remember how to. Yeah. Okay.
you want to finish it?
Yeah. Okay. So B is 26.
Right.
So it's y equals negative 7x plus 26.
Okay, so if you start off with that equation, how do you find both the y and x intercept using the equation?
The y x intercept. Uh,
Because
you just
I want to
you
find that point right there.
you plug in the y,
What
just
is
one
the
of the y's
what is the
into
y there?
0.
Okay.
So yeah, 26/7.
Okay. What if I were to do this? Okay, I'm gonna do it this way. Hold on. Do you know how to graph that?
Yes, I believe so. Hold on, let me grab my pen. Whenever you graph it, it would be a solid line, and then you shade the half, right?
Yeah, so which side of the line am I going to shade on, the left or the right?
The left.
What about this?
It'd be another solid line, and you'd shade on the other side.
Okay, so this is that line. So I'm going to do it in a different color. So what's the solution of that system of equations then?
It's the middle in between those two lines.
Yeah, and I'll do that in a different color. Okay. So you fundamentally know how to do the math, right?
Mm-hmm.
So I'm going to do this then. I'm going to ask kind of the exact same question a different way. So, there are two ways in order to answer this question. Can you figure out how to do that combination inequality? How would you write that? Do you know how to write it as two separate equations? Do you know how to do that?
No.
Okay. So this is what I'm going to do. I'm going to take half of this and I'm going to write it as a separate equation. See how I did that?
Uh-huh.
And then I'm going to take the other half and write it as an equation. Do you see how I separated it?
Yeah.
Now, can you graph each one of those for me? The easiest way to graph them is by using the intercept formula. So find the x and y intercept of both equations. That's the easiest way to do it.
How do you find it when it just gives you the one number?
Okay. Well, how do we find the intercept before? When I was looking for the x-intercept, what did I do to the y? I just did that. Because you told me how to do it.
You filled in with the other number.
Okay. This is what I'm saying. So if I'm looking for the x-intercept, I'm going to take this y, and I'm going to make it 0. Because isn't y 0 along that line?
Yeah. Oh, okay, I see. So just the x would be -3.
What would the y be?
The y would be 0, right?
The other y point, what would the y-intercept be?
Oh, the other y. Make this 0. So it would be 1.
Okay. Maybe I'm not explaining myself right. I'm just dealing with one equation at a time. This is what I want you to see. So I found the x-intercept by making the y 0. How do I find the y-intercept? What do I do to the x?
Make it a 0.
Make it a 0. So what would the y be?
-3.
And now all I got to do is just graph the line, right?
Mm-hmm.
Is the line solid or dashed?
Dashed.
So that's one of my lines. Am I shading to the left or to the right?
To the left.
Well, let's look at this. If I have to say that y is bigger than -3. So if this is my -3 down there.
Wait, your video your sound just cut out. What'd you say?
I said my y is bigger than -3. That's my y, right?
Right.
Give me a number bigger than -3.
-2.
Where would that be?
Above it.
So am I going to shade to the left or to the right of that line then?
I'm gonna shade to the right.
Do you see how I figure that out?
Yeah.
You just use one of the numbers and then shade to that side. I always use the y.
Okay.
So now I'm looking at this point because I got that line and I got my shading. So I want you to do the exact same thing with that. Tell me where to put the points.
Okay. Sorry about that. I'm really rusty.
That's all right.
So here, place the Y equals 0. So the x would be 1. And then the y would be 1 also.
Line solid or dashed?
Dashed.
Shade to the left or to the right?
Less than 1, so to the left.
And so the region that we're actually going to shade is in between the two, right?
Mm-hmm.
So my thing is, when you're doing stuff with lines and you're doing shading of lines, use the intercepts in order to graph the line if they give you the equation. That's the easiest thing to do. That's the skill that I want you to use.
Okay.
So we're going to go now. We're going to go back to your. We're going to go back to your diagnostic tests. I got to find that question. Do you have your diagnostic test there by any chance?
It should be. Yeah, I have. What question was it?
Hold on, I'm waiting for my computer to get there. This thing is really driving me nuts. Oh my god.
Okay, I got it. It was 36.
Okay, so you missed that question. Can you tell me what the right answer is now by using that technique?
Yeah.
What is going on with my computer?
So it would be J.
Correct.
Okay.
Okay. There we go. Just FYI, how would you do a perpendicular slope? What do you do to the numbers?
You reverse them, right?
You flip them and make one negative.
One negative.
Okay. 44 you got right. Hold on, I'm trying to look for all the linear questions on here so we can now fix them. Okay, go to question number 39.
Okay. Oh, so it'd be B.
Yep.
Okay. I don't know why this is. Oh, I put y1 minus y2 instead of y2 minus y1.
Okay, let's do this. So I think you missed 42. Okay, so I'm going to draw a shape. This is A, this is B, this is C, and this is D. And I want to reflect that shape across the y-axis. Which axis is the y-axis?
Wait, which one did you say?
The y.
Oh, the y is this one.
Okay, so if I take this point A and I move it over here somewhere, because I'm going to go across that axis, does the y value change?
No.
No. So I just need to move it the same distance away in the x. So what is that point there?
That is 1, 2, that's 3, 1, 2, 4.
Right? And I know over here my y value doesn't change. What happens to the x value?
Becomes negative.
It becomes negative.
Negative.
That's the only thing that happens when you reflect something, right?
Uh-huh.
So if we look at question 40, what would the answer to that be?
F.
F. What are you laughing about?
What?
I said what? I said, did you say something? No.
No.
You see your mistake there, then, right?
Yeah.
Yeah. Okay. Do you remember the distance equation?
No.
Okay. So let me go over that.
I'm sure I'll remember it once I see it. I can't remember it.
Okay. I grabbed the wrong line. I'm going to show you something. You actually already know it. You say that this is y2 minus y1 over x2 minus x1, right?
Right.
And that's slope.
Uh-huh.
Well, here's the only difference between that and distance. I'm going to take this first part and I'm going to move it underneath the square root sign. And then just square it. And then it's plus this thing. And then I'm going to square it. So what this is actually saying is take the x's and subtract them and square it. Take the y's and subtract them and square it.
Mm-hmm.
And then add them together and do the square root. This is actually just Pythagorean theorem too. So if I have, that's a bad line. Hold on. So let's say I want to know how far it is from this point to that point. Go ahead and use the equation and tell me what that would be.
So it'd be square root of 1. I got the square root of 1.
Okay. What are the coordinates for that point up there?
Oh, I reversed it. Okay. I put 4, 0 instead of 0, 4. Okay. 1 second, sorry.
That's okay. Take your time.
That's what I do a lot, it's careless mistakes. So it'd be 5.
So it'd be 5. Let me show you how you can make any line a right triangle. Okay. If I count from there to there, how far am I going?
You're going down 4.
Is that 4 or is that 3?
1, 2, 3. Oh, you're going down 3. Okay. I see.
How far am I going over this way? Ooh, sorry. My computer's acting up.
4.
So now I have a right triangle, right? Because this is a right angle there, right?
Uh-huh.
What does Pythagorean theorem say?
A squared plus b squared equals c squared.
Isn't that the same thing that you got here?
Oh, yeah.
So as long as I can find 3 solid points to make a line, I can just use Pythagorean theorem and not this equation, so I won't mess it up.
Okay. That makes it a lot.
That's easier to do, right?
Yeah.
So let's look at the question that's on the diagnostic test. Okay. So I want you to look at 44 and see if you can make a right triangle to figure out. Okay, so it says.
Are you looking at 44?
Yeah. E is 6.
Wait, no.
D lies EF. Actually, I think I would use elimination to do this question. Actually, never mind. You got that question right. Never mind. Sorry. Let's not do that.
Which one?
Right. I just saw another line question, and I just figured you. I apologize. You got it right. Okay, I think that's the last of the linear ones that you missed. So let's go to angles and triangles. Look at the bottom of this. All right.
Are these sessions going to go for an hour each?
Huh?
Are these sessions going to go for an hour each?
Yeah, they're going to go for an hour each. Is that okay?
Yeah. That's fine.
Actually, I want to do some parallel line stuff first before I do triangles. So, here we go. Okay, just another review question. If I mark this angle as x, what are the other angles that are equal to x that are drawn in this picture?
This one. This one. And I guess this one.
So, if I call this A, what would be the name between those two angles?
What?
If one angle is x and the other angle is A, do you know the relationship between those two? Besides them being equal, do you know the name? What are they called?
Oh, crap. It's like,
Starts with a C?
corresponding.
There you go.
Yeah. Okay.
How are B and X related?
Vertical.
How are A and B related?
What does it start with?
A.
I forgot.
Alternate interior?
Alternate interior, yeah.
Whenever you have an alternate angle, it's always going across this line that's called the transversal, so that middle line, right?
Yeah.
And then C and X are alternate exterior angles. So anytime you see a parallel line question, when I'm doing a parallel line question, I always just mark the angles that are equal, because if they're not equal, then they're equal to 180. So like if I write D here, if I add D to any of those other angles, let me make D a different color. If I add D to any of the other red angles, it's always going to be equal to 180 because they're already supplementary. That's that geometry term, right?
Yeah.
So I'm going to give you another picture. So just remember that. So whenever you have a parallel line question, either the angles are equal to one another or it's 180.
Okay.
Oh, bad line. Okay, this is a classic ACT, SAT question. They're going to say that, let's say that this angle up here is 100. And this angle here is 20. And they want to know what this angle here would be. Did I write that right? Hold on one second. I want to make sure I drew that right. I got to draw them on the same side. Hold on one second. That's actually how the picture's drawn. You can do this question in one of two ways. What I tend to do is I actually just extend one of the lines. So I'm going to make a triangle. So I'm going to take this line here and I'm just going to extend it. Okay. You see that?
Mm-hmm.
So if I look at 20 and this angle, what can I say about those two?
They're equal to each other.
They're equal to each other. So what's that equal to?
20.
So if I'm looking for this angle here, then there's something called the external angle theorem. Do you know what the external angle theorem says?
Nope.
If you have an angle that is outside of a triangle, and I will redraw this so you can actually see the triangle. You see how that green angle is outside that blue triangle?
Uh-huh.
Then the blue angle has to be equal to the two angles on the opposite side. So that means that this is equal to 85. I can do the question exactly the same way by extending this line. If this is 65, then what is this angle?
65.
Then what do you get when you add those two angles together?
The 60.
The 65 and the 20 in the bottom triangle? You see how that's the same answer? If you don't see the 65 and the 20, you see how no matter which triangle you do, you still get the same answer? Do you see that?
Okay. Yeah. So that would be 85 also.
Right.
Okay. I get what you're saying.
So just extend the line, either that or just remember that these two angles are always going to be, you add them up, it gives you the middle one.
Okay.
So let's go back to your diagnostic test. Question number, oh, you actually got that one right. Never mind. How did you do that question, by the way?
Guess, probably.
Okay.
Because I didn't know what you were doing. Wait, which question is it?
Question number 8.
8?
Yeah.
Question number 8?
Am I on the wrong thing? Oh, okay. Never mind. I'm on your homework. Sorry. I'm on the wrong one. diagnostic test. Hold on one second.
Okay.
Oh, they didn't actually ask you that. Okay, well, I had to cover that anyway because it's actually part of your homework. So,
Okay.
you have your homework sheet there, right? Did you try opening it up yet?
Yeah, I got it open.
Go to question number 8 of the diagnostic test. That's because it said diagnostic test on it, so I thought I was looking at the same test.
Oh, okay. You want me to do question 8?
Yeah, go ahead and do question 8 for me.
What does it mean find the number of degrees in an angle FE?
It's asking you to find the angle.
Just find the angle.
Yeah, it's just worded weird. It's just asking you to find the angle.
This. So it'd be 70.
Right. Good. Okay.
That question looks hard, but it's actually easy.
Right. Okay. Here's the last thing that I'm going to leave you with, and then I'm going to tell you what your homework is. Okay. We talked about triangles. And when you're doing the Pythagorean theorem, there are these special triples that come with each one of these right triangles. I already did one. So if this is my triangle, and this is 3, and this is 4, then that's 5. That's the first one that we did today. So let me show you how to use this and how they're going to hide it from you. Let's say that this is 9 and this is 15, and they want to know that side. You could use Pythagorean theorem to find this, but you also said in your note that you want to figure out how to do stuff faster.
Mm-hmm.
So you can use this technique to solve most of the right triangles that are on the test, because almost every single right triangle on the test is a triple. And I'm going to give you like 7 different ones. But you can use this technique for all of the triples. The first thing that you do is you find the number that 15 and 9 have in common. What's a common factor of 15 and 9?
3.
3. So I'm going to write that here. If I take the bottom number and divide it by 3, what number do I get?
3.
If I take this and divide it by 3, what do I get?
5.
So what number is missing out of the triple?
What do you mean?
The triple is 3, 4, 5. That's the triple.
Oh, so 4 is missing.
So you put 4 inside, and then you just multiply those two numbers together. What do you get?
12.
Has your geometry teacher never taught you that?
No.
You guys did right triangles though, right?
Yeah, I just used Pythagorean theorem.
Okay. So the trick is find the number they have in common, figure out which triple you have, and then just multiply. That's all you have to do. You don't have to use Pythagorean theorem. So here are some of the triples that you're going to see. 3, 4, 5, 5, 12, 13, 8, 15, 17. I don't know why this won't write. Uh, 7, 24, 25. Now I'm having a brain fart. 20, 21, and 49. And then you have 1/2. Actually, I'm going to do it this way. You have 1, the square root of 3, and 2. It's like 1, 2, 3. This is a 30, 60, 90 triangle.
We learned about that.
And then you have 1, 1, square root of 2. And that's your 45, 45, 90 triangle.
Okay.
Now, all of those, if you find the common number, you can just use the triple in order to answer the question. So I want you to do this one for me.
So it'd just be 21. You just use the triple. Oh, wait. 21.
It's not 21. What number do 24 and 45 have in common?
6.
6 doesn't go into 45.
Oh yeah. 45. 3 goes into both of them.
3 goes into both of them. Divide them both by 3.
So 8 and 15.
What's the missing number?
18.
Which one of those triples have both 8 and 15 in it? Oh, does it look like 18 on your side? This is actually 17. Sorry.
Oh, okay. So 17.
So what's 3 times 17?
51.
That's how you find your answer.
Okay.
Do you get that?
Yeah. Can you also solve it with Pythagorean theorem also?
Yes, but the Pythagorean theorem takes longer.
Yeah. Okay.
If you memorize the triples, you can almost get the answer instantaneously once you practice it enough.
Uh-huh.
And what they'll do is they'll take this triangle and they'll stick it inside of a circle to try to hide it. And so we'll work on that kind of stuff later.
Okay.
All right.
And those are all the triples that they can use?
I know I'm missing one, but I'll give you the, because there should be 7 of them. 1, 2, 3, 4, 5, 6. Oh, there's 7. Okay. Those are the ones I use the most.
All right.
Those 7.
Okay.
All right. So let's talk about your homework. Okay. So your homework for me is that pack of geometry, the geometry PDF that I sent you.
Mm-hmm.
I want you to take the diagnostic test again. So I want you to do that.
The same one I already took?
No, it's only 10 questions. It's only 10 questions. Most of which we already covered.
Oh, okay. So just those 10 questions.
And hold on. I'm going to tell you which exercise I want you to do. I want you to do exercise 3.
Exercise.
And exercise 4, because we talked about lines. And exercise 4 is like, they're like 5 questions. It's not going to take you very long.
Okay.
And exercise 5. So I think it's like 20 questions altogether.
3, 4, 5.
Do you have any questions for anything that we did today?
Nope. I think I'm good.
Most of it was basically review. I just had to refresh you, right?
Yeah.
Okay.
You want me to? Okay.
You don't have to send it to me. You can keep